This section deals with polysynaptic reflexes. That is, there's more than one synapse in the central nervous system. That would mean there are interneurons involved here. A withdrawal reflex is polysynaptic, and with a withdrawal reflex, you're going to move away from the stimulus. So imagine putting your hand in hot water, and you withdraw your hand versus grabbing a burning hot pan with your hand. You're going to have a greater withdrawal reflex with the more painful stimulus. The flexor reflex is a type of withdrawal reflex affecting muscles. So you grab a hot pan, pain receptors are stimulated, sensory neurons send information to the inner neurons in the spinal cord. The inner neurons stimulate motor neurons in the anterior gray horn, and that results in contraction of your flexor muscles. But there's something going on here, and it's called reciprocal inhibition. So we'll see what that looks like in a second. So here you are grabbing your hot pan. Information comes in through the posterior root ganglion, synapses, and motor information goes out to your flexor to flex your arm, but at the same time as you're flexing your biceps, your extensors, your triceps brachii must be inhibited. That's reciprocal inhibition. So it deals with muscles, the agonist or prime mover and the antagonist. One must be relaxed in order for the other one to contract. That's reciprocal inhibition. Stretch reflexes and withdrawal reflexes use ipsilateral reflex arcs, or where the sensory stimulus and motor responses are on the same side. A little more involved is the crossed-extensor reflex. That involves contralateral reflex arc, or opposite side. So let's imagine you step on something sharp. Before you can flex your leg and pick up your foot, on the opposite side of the body, you have to extend your leg to receive the body weight, and then your injured foot can be lifted. There's a lot going on here. Just read through this. So you step on your right foot. In order to lift that right foot up, you have to extend your left foot, shift your weight over to the left side, and then you can flex your right damaged foot. Polysynaptic reflexes are also responsible for walking and running, these complex movements. There are 5 properties to these. They involve interneurons that may be excitatory and inhibitory. They involve multiple spinal segments. They involve reciprocal inhibition. They have reverberating circuits. And several reflexes may cooperate to produce the coordinated response. Which of these is an autonomic or automatic reflex? Salivation. Which of these is not involved in locomotion, running and walking? Autonomic reflexes.